simulation studies using Comsol for reaction as well as biochemical reaction engineering. In this process, first we need to create a file. When you create a file using Comsol Multiphysics, there are two components is there. One is model wizard. It is an inbuilt function, whereas blank wizard is a model in which a function can be customized. Now we are going to use a model wizard where all the functions are going to be inbuilt. So choose this. The space dimension are of 6 different types. One is three-dimensional model, two-dimensional axis symmetry, two-dimensional, one-dimensional axis symmetry, one dimension, zero dimension. For reaction generating space, we could choose 0D, then choose reaction engineering, add reaction engineering, then go for steady. Since the reaction is a time dependent process, we choose time dependent and create that. Now the model builder setup is there. It is divided into 3 categories. One is we need to assign the reaction types, then we need to assign the reaction initial values, then the time dependent process we need to compute. For that, we need to give an equation in the settings. Then you will be getting a result in the graphics. So first I create a file as a reaction. The formula for reaction is A gives B, then apply. It's a simple chemical reaction. When A gives B, it is going to be a function of rate constant. That rate constant we need to assign 0.654, an example. Here we could also go with the Arrhenius equation by providing the temperature and Arrhenius constant everything, since it is easy for us to give the rate constant. The alternative is Arrhenius equation can also be used. Then after assigning this, the initial value is going to be 100. Now initial condition is given, the equation also provided. Now we'll go for compute, plus compute. We'll be getting the results. From 100, it is going to be decreased. Then B is going to be formed. Find out the time to extend the time interval. Plus instead of 1 to 10, then go for compute. This is the results we'll be getting. An example, again, you are going to change the time from 10 to 50. You can see the profile. So this is the thing we can able to simulate. The entire report can also be, we can download from the export report or reports. And let us try for a consecutive reaction. For consecutive reaction, provide reaction, then A gives B, press apply, then again reaction, B gives C, apply, and third reaction, C gives D. So there are 3 reactions That is, A is going to be reduced to B. Again, B further reduces to C. C further reduces to D. All these are going to be follow a rate constant. So, first equation rate constant, let us assume it as 0.854. Second reaction rate constant is 0.6. Just assume it as 100 mole. Now, based on the time dependent, we can compute. So, this is the reaction. Here, A is reduced, B is formed, C is also formed, D is also formed. When you change the time interval from 1 to 10, and go for compute. So this is the reaction mechanism that is taking place for the consecutive reaction. The same way we'll also try for a non-elementary reaction. Now let us try for a non-elementary reaction. This non-elementary reaction, I just taken it as reaction A equilibrium to B, then apply. Here both forward as well as reverse reaction is going to be taking place. So we need to give the rate constant for forward as well as the reverse reaction. Then another reaction is B gives C, apply. Now the rate constant for forward I can assume it as 1. The rate constant for a irreversible reaction I assume it as 1.5. Now all the conditions are given. Then A assume it as 100. Then go for times the compute. So this is a reaction mechanism, kinetics for a chemical reaction. Here you can also change the time interval from 0 to 10 with the interval of 0.1 and compute. This is the way we can able to predict the kinetics of a reaction by using the rate constant. The another example is enzymatic reaction. So in enzyme kinetic reaction, what we can do is we can go for reaction. This is an enzyme E react with substrate S, forming a reversible reaction, gives ES, apply. The next reaction is ES further reduced to E plus P. So there are two steps of reaction. Enzyme substrate react and gives enzyme substrate complex. This is going to be an unstable form of reaction. Both forward and reversible reaction is taking place. The next one is intermediate reaction of compound which undergoes further reduced to enzyme plus product. It is an irreversible reaction. The rate constant for this is, let us consider the rate constant